I will discuss about the operating point of an amplifier circuit. You know very well that transistor is the key element of an amplifier circuit. Transistor is a 3-terminal device. And what is an amplifier circuit? Let us recall. It is the circuit which amplifies an input signal. Signal can be a current signal, a voltage signal, or a power signal, and accordingly we can define a particular amplifier. Symbol of the transistors, how we draw it, what does it mean, what are its parts, that we know very well. We have studied it earlier. Two types of transistors, PNP and NPN, that again we know, and these kind of transistors are used in most of the amplifier circuits. Let us come to the point, what is operating point? When a transistor is operated as an amplifier, there are basically three kind of circuit connections possible. If we keep one of the terminal common, then the other two terminals makes either a common emitter amplifier circuits or a common base or common collector circuits. In amplifier circuits, most of the times common emitter circuit is preferred. It has many advantages. Okay, what is the operating point then? First of all, when an amplifier circuit is prepared, the transistor requires some DC energy, and that is called as the biasing. So we need to bias a transistor to perform process of amplification. How that can be made? For that, in common emitter board, normally transistor, the input junction is kept forward bias and output junction is kept reverse bias. Likewise, we connect the circuit, then we get a common emitter amplifier circuit. Then what is operating point? Again see. Now for a common emitter circuit, if we draw a graph of its output current, collector current, against the collector voltage, that is the output voltage, keeping input constant at some value, then we call it, or we get its output characteristics. Here we are discussing about common emitter board. I will show you how the common emitter circuit and its output characteristics can be determined. Let us see. In this way we can get a graph, and this graph represents the output characteristics. Okay, now suppose, as we have seen in the circuit, if a load resistor is connected to the collector, say RC, then this load along with the supply voltage VCC, as we have seen in this circuit, determines the DC load line of the circuit. The DC load line can be drawn by using a technique. We get a set of point by doing the analysis, or simply applying Kirchhoff voltage law to the output circuit and get the coordinates of x and y axis. Say at x axis for common emitter circuit we get two coordinates like VCC and 0, and at the y axis VCC by RC, and like that. If we solve it by Ohm's law at the output of the Kirchhoff law at the output circuit, how that can be derived? Let us see. As we know, when we bias the transistor, the output characteristics is split into three parts: cutoff region, saturation region, and the active region. Now the DC load line, as we see in the graph, intersect with characteristics curve at a particular point. This intersection point of particular characteristics and the DC load line is known as the operating point. If we look in the circuit, there are many points where the DC load line is intersects with characteristics. So as for examples, for different values of IB, that is input current, we have different intersection points. All these intersection points are called as the operating points. So what is operating point? That now we have determined. How we can define that? So it is the set of three values, namely a base current, that is the input current, collector current, that is the output current, and the collector to emitter voltage, that is VCE. The set of all these three values determines the operating point. As we can see in the characteristics, we have many operating points. Now the question is, which is the best or which is the more suitable operating point? More suitable in which sense? which operating point gives us a better amplification process. So let us proceed for the selection of operating point, that out of these many operating point, which is the best operating point. Let us see. As you can see on the output characteristics, we can select operating point anywhere in the active region. We start with the first case. Suppose the Q point or operating point is near the saturation region. In that case, the input signal IB can be projected as can be seen in this slide. Now, when the operating point is near the saturation region, the input current IB gives the corresponding collector current as well as the collector voltage. If you look carefully in the slide, you will find that the output current, that is collector current, is not flowing for that part of the input current. During that, the input current drives the transistor into the saturation region. As long as IB flows in the saturation region, the collector current remains constant, and as a result, the collector current IC is clipped at its positive peak. Similarly, if we take the projection of the collector voltage, we find a clipping at its edge also. So from this, what we conclude, that if the operating point is near the saturation region, output signal is clipped at its positive peak. So we don't get a perfect amplification of the input signal. That is not desired. So in conclusion, we decide that to keep the operating point near the saturation region is not beneficial or not advantageous. Then where it should be? Okay, we take the second case. Suppose that the operating point is near the cutoff region. Under this case, we will find that clipping will happening at the negative peak. So this is also not suitable operating point. We take the third and final case, that if the operating point is selected or established exactly at the center of the active region on the load line, let us see what happens. Okay, we have seen that if the operating point is at the center of the active region on the load line, we get a perfect sinusoidal output at the collector as well as at the collector voltage also. So both collector current and collector voltage are perfect sinusoidal. In this way, we can see that we have a proper amplification. This is how we can select an operating point. And the last case, again, if the operating point is selected at the center of the active region, but the input signal is too large, we get a distortion on both the peaks. Let us see that. Okay, you have seen the case that if the input is too large, although the operating point is at the center, it gives us the distortion. So finally, what we conclude, where should be the operating point? The operating point should be at the center of the active region on the load line. Only then we get a proper amplification of the input signal. Friends, I hope you must have understand what is operating point and how it can be selected for proper amplification. You can see the reference book or resource for this material, as you can see those books, Basic Electronics and Linear Circuit by Bhargav, Kulshrestha and Vasisht. This will give you more details regarding operating point and amplifiers. Thank you.